This is Kristian Anthony F Reyes from 4th year Maxwell, and I will discuss some topics about derivatives. So, derivatives. Derivatives is said to be the slope of the tangent. So, we're going to use y prime to denote derivative. So, its definition, so, limit of f of x plus h minus f of x is equals to h as h approaches to 0. So, that is the formula we're going to use. As shown in the formula, f of x plus h, so we're going to substitute x plus h to all x in the function. So, for example, f of x is equals to 2x squared plus 3x minus 1. So, that is our given. So, it will be 2x plus h squared plus 3x plus h minus 1 and minus f of x, which is the given function, which is 2x squared plus 3x minus 1 over h. So, we're going to evaluate all the operations. So, it will become 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 1 minus 2x squared minus 3x plus 1 over h. So, let's cancel all the possible terms. So, we're going to cancel 1, 3x, 2x squared, since they're all equal to 0. So, limit of 4xh plus 2h squared plus 3h over h as h approaches to 0. So, let's cancel all h. So it will become 4x plus 2h plus 3 as h approaches 0. Another example in finding the derivative of a function. So, the process of finding the derivative of a function is called differentiation. So again, we're going to use the formula limit of f of x plus h minus f of x over h as h approaches 0. So we're going to substitute all x plus h to all x in a function. So, square root of 3 quantity x plus h minus 1 minus f of x, which is square root of 3x minus 1 over h. Then, let's distribute 3 to the x plus h. The equation will become square root of 3x plus 3h minus 1 minus square root of 3x minus 1 over h. So after distribution, we're going to find its simplest form. So in finding its simplest form, we're going to multiply this to square root of 3x plus 3h minus 1 plus square root of 3x minus 1 over square root of 3x plus 3h minus 1 and again plus square root of 3x minus 1. So, we can cancel all the square root in the numerator and it will become like this. Then we're going to cancel all the possible terms. Then we're going to cancel the 3x the 1, then the h. It will become 3 over quantity square root of 3x plus 3h minus 1 plus the square root of 3x minus 1. Since h is equal to 0, we're going to exclude the 3h. It will become 3 square root of 3x minus 1 plus the square root of 3x minus 1. Then again, we can add these two terms and it will become 3 over 2 times the square root of 3x minus 1. That is now our derivative. So again, the process of finding the derivative is called differentiation. So before, we got 4x plus 3 as the derivative of the function 2x squared plus 3x minus 1. We can make the equation simpler in finding the derivatives. We can simply use the derivative of sums and differences. So in finding the derivative using the sums and differences, so the steps are: first, we're going to multiply all the exponents to the coefficient of the term and subtract 1 from the exponent. So, our given before is f of x is equal to 2x squared plus 3x minus 1. So, 2 times 2 is equals to 4x plus 3. So, again, there's no need to include this negative one because of the constant rule. So, our derivative will become 4x plus 3. Simply as that. Before, we got 3 over 2 squared times the square root of 3x minus 1 as the derivative of the function square root of 3x minus 1. So again, we can make the equation simpler by using the general power rule. In getting the general power rule, first, we're going to make this radical form into exponential form. So it will become quantity 3x minus 1 raised to 1 half. Then it's just like power rule, but instead of only one term, we're going to multiply the exponent to the whole function. So it will become 1 half times quantity 3x minus 1 raised to negative 1 half, then the derivative of the function. So only 3. Then since the exponent of this function of this term is negative 1 half, we're going to put this function to the denominator. So it will become 3 over 2 times the square root of 3x minus 1 raised to 1 half, and it will become 3 over